Welcome back. Today we're going to be discussing force vectors. We learned about force yesterday, and today we're going to be discussing vectors. Um, some of this will be review. Vectors have both magnitude and direction. Um, Vector notation. Vectors are given a variable such as A or B. Handwritten notation usually includes an arrow such as um, something as simple as that, or a little dash above it. So and that's what they mean by when they're talking about vectors. Illustrating a vector. Vectors represented by arrows include magnitude, direction, and sense. The magnitude of this would be 3, and we kind of talked about that in yesterday's notes here. If this right here had a distance of 3, then this vector right here would have a magnitude of 1 because we want to keep them proportional. If I wanted this to be this right here, if I had a vector this long, then we would say it would be a magnitude of 2 because it's about 2 of these units long. We also try to draw them in at a close to the angle that we can. So the direction here would be 30 degrees, and the sense would be up and to the right. So it just makes sense to say it's going up and to the right. As I'm thinking about this, there's one difference that we'll talk about here, and when we talk about direction, we'll typically say clockwise or counterclockwise from an axis, whether it's the x-axis or y-axis, and that kind of is a little bit different than what we did in physics, but I think you guys will catch on fairly quickly. Um, a lot of our math here is going to be based off a right triangle. We're going to use the Pythagorean theorem specifically, and this here can be used with a 90-degree angle. The other math we're going to use is from Algebra 1, trig functions here, SOHCAHTOA. I know you use it in Algebra 2, use it a lot in trig, but SOHCAHTOA is a way that we use to remember this, and basically this means the sine equals the opposite over the hypotenuse. So cosine is the cosine equals adjacent over hypotenuse. TOA. Tangent equals opposite over adjacent. Hopefully this is a review for most of you guys. One of the things I want to talk about here is the longest side is always labeled the hypotenuse. The longest side is always the hypotenuse, and in a lot of our thing we're just going to call it F. It's the vector F. The adjacent side is what we call the x, and it's going to be f of x. It's called f of x. The opposite side is the one that's the opposite or across from the angle, and that's what we call the opposite side. It's f of y, f sub y, but usually f of y is how we'll refer to it. Two main equations I want you to get down, and here's one of them, and here's the other. What they've done here now is they went ahead and solved the equation for the variable or for the vector f, and you take it times the sine of theta, and that gives you the opposite side. You take it times the cosine of theta, and that's going to always give you the adjacent side. We're going to use that quite a bit. Okay, vector and xy components. What we've got here is we've got vector A. I did not mean to move it there. Sorry. We've got vector A here. It's 75 pounds of force behind it, and it's moving at a 35-degree angle. It's moving counterclockwise. All right, counterclockwise. You have to go counterclockwise from the x-axis. The sense is to the right and up. Well, let's go ahead and find f(x), meaning to break this down into its x component. To do that, we're going to use our equation over here that we've already given you. And f is going to be 75. F of x equals 75 times the cosine, in this case of 35 degrees. When we do that, we get f of x to be 61.4 pounds. So f of x down here is 61.4 pounds, is the length of the magnitude. All right, that would be the magnitude of fax, or fx. I keep saying fax. Let's call it fax. There we go. The next one now is to find fay. Alright, so find the length of vector fay over here. What we're going to do then is the same thing. I'm going to say f of y equals 75 times the sine of 35 degrees. And we find out that and I'll say FAY, you're going to see me keep making that mistake, so it's not something I'm used to, is that it's going to be 43.0 pounds. So this over here is 43.0 pounds. So what we've done now on the last two slides is we've broken this down into its X and Y components. Um, Now here's what I want you to go about finding on your own. So go ahead and pause this, and I'll give you a few seconds to do that so that you can go through and find these on your own in the homework on your notes. Okay, hopefully you've gone through and found this now. Again, if you haven't, go ahead and pause it here and find them, but I'm going to take you through them now. F of x is f. What was f? F was 75. Cosine, because I wanted to find the x, all right, the adjacent side, so I'm going to use the cosine of 25 degrees, and that turned out to be 68.0. It was actually 67.97, and I rounded that up to 68.0. The next step then is to find the y component. Well, the way we go about doing that again is taking the hypotenuse, which is 75, vector f, and we take it times the sine of 25 degrees. And when I did that, I got 31.7 pounds for the length of the opposite side. Well, what if we have two vectors? And this is what can be used now. We're going to use this to break this down and find out what the resultant force is. Let's assume we have two people pulling on a rope on this boat, trying to pull it up onto shore. But they're pulling at slightly different angles. One's pulling at a 35-degree angle, and the other one's pulling at a 25-degree angle. So what we're going to find out is the resultant forces are a little bit different of what's going to happen to the boat. Now what I've done here is, and let's backtrack. The nice thing I've tried to do is to keep this measurement, all right, and this measurement the same. So what that means then is our y component and our x components are going to be the same as what we just got done calculating. And hopefully you can see that. The only difference here, is hopefully you can see that right here, is it's still a 25-degree angle and it's 75 degrees. And the reason I did that is so that we could kind of speed this process up. Right here, it's telling us what f of x is going to be. So it's going to be 68. So I'm going to go back here and I'm going to put 68 right here. This is what the FBX was, 68 pounds. Now we got to remember what was y. Well, y, we said the f of y was 31.7 degrees. So this was 31.7. We've already did this math. Now we're just saying, let's pretend that one student in this class was pulling up here at 35-degree angles, 35 equal to the 75 pounds, and someone else was pulling down here down and to the right with 75 pounds at this angle. So we're just using the same math because it's going to have the same resultant. Now, as I look down here, there are these two forces now in the x direction, 61.4 and 68. There's two forces in the y direction. One's pulling up at 43 and the other one's pulling down at 31.7. And I'm going to call this negative because it's in the negative direction. And if you kind of look at this right now, you're going to tell that these two are going to kind of somewhat cancel each other out. So what I've done here now is I've went ahead and just kind of did the sum. And we're starting to learn that this symbol is a Greek letter, but it means sum. And I filled in what the second person was. They had a force of 68 pounds for a total of 129.436 pounds pulling to the right. If we take these two people, one was pulling down and one was pulling up, and their kind of forces in the y direction, we're going to cancel each other out to an extent. You're going to get 11.318 pounds net force in the upwards direction. Well, what I want to point out here now is we still don't know the resultant magnitude. I mean, this boat is going to be pulled to the right, but it's also going to now be pulled to the up position. It's going to move to the right and up on our picture. We don't know the overall direction. We kind of have an idea of the sense now. It's to the right and to the up. What we get here now is we get these two vectors, these two force vectors. We had 129.436 pounds to the right and 11.31 up. What's going to happen then is the boat is going to have this resultant vector, and it's going to move in that direction. It's not going to move just to the right, and it's not going to move just up. It's going to move to the right and up because it has this net force pushing on it. So let's use the Pythagorean theorem. Let's have you guys go ahead and find C here. So go ahead and pause it, find C on your own. Well, what we find out here then is C has a resultant force of 129.9 pounds. And what that means is the boat is going to be moved in this direction to the up and to the right as if it had one rope pull being pulled on it in that exact direction at 129.9 pounds of force. What we don't currently know, though, is that exact angle of theta. What angle is that resultant force of C? What force or what direction is that being pulled at? Well, the way we go about doing that then is we can use our tangent function. The tangent, because it involves the opposite side and the adjacent side of the angle that we're trying to find right now. So this is my opposite, this is my adjacent. So I can say tangent of theta equals 11.318 over 129.436. How do we go about doing this? We use the inverse tangent, and I can tell you more about this in class. And when you do that, that's when you use the tangent function, just the tangent, you're trying to find the side. When you use the inverse, you're trying to find the angle. Alright, and I guess you're not going to get that if you're not listening. So hopefully you guys are listening and not just looking at this. So what we did here is we took the tangent of this, and I went ahead and divided that out and got this number here. So then I took the inverse tangent. So while this is my calculator, in my mind's an iPhone, so I have to punch this number in and then hit the inverse tangent. Your calculators could be different, but I got an angle of 4.99. So I rounded that up to 5 degrees, and it's clockwise. If this right here is my x-axis, here's my x-axis, it's going up. Alright, and that's actually counterclockwise, isn't it? Counterclockwise, because it's going up, it's not clockwise. So it's 5 degrees counterclockwise from the positive x-axis. Well, hey, I hope this has been informative information here over vectors. Some of you it'll be review, some of it's brand new. At any rate, I'll catch you on the flip side.